Hello everyone, and welcome to the NEATEC Electronics Series. This episode will concentrate on Thevenin's Theorem, so let's get started. Alright everybody, so let's talk about Thevenin, shall we? And you pronounce it Thevenin, just like it's written. Thevenin. And he has a theorem, and it's called Thevenin's Theorem. Okay? So, this is a very useful theorem, and it's going to be useful to you in your study of electronics because it's going to enable you to simplify complex circuits. Alright? So, Thevenin's theorem provides a method for simplifying a circuit into a standard equivalent form with respect to two output terminals. This theorem can be used to simplify the analysis of many complex circuits. Alright? So it has two things. Where are we going here? Let me just make this in blue just so you have it. When you're doing this analysis, you're going to have VTH, that's your Thevenin voltage, and you're going to have RTH, that's your Thevenin resistance. And when you draw your circuit, your equivalent circuit, you're basically going to have a source like this. This is going to be your VTH. That's an H there. I drew that a little fast, I'm sorry. And this part is going to be your RTH, your Thevenin resistance. And most times then between 2 points like this. And then you may have a resistor or something that goes in between here in your analysis. But they're in series, right? You have your voltage, your Thevenin voltage, and then in series with it is your Thevenin resistance. The Thevenin equivalent voltage, VTH, is the open circuit no-load voltage between two output terminals in a circuit. Any component connected between these two terminals effectively sees the Thevenin voltage, VTH, in series with RTH as I just drew. Got it? So the Thevenin equivalent resistance, on the other hand, is the total resistance appearing between the two terminals in a given circuit with all the sources replaced by their internal resistances. Alright? So, most times the internal resistance is extremely small, so we just neglect it and we call it a short. Alright? So let's do an example, shall we? This is probably the best way to do this. Let's take this out. There you go. Alright? So, let me just draw a basic circuit here, shall I? Shall we? So, let's draw a circuit here. I'm sorry. All right. Boom, 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 up. Now, come over, come down. That's one. There's another one, right? By the way, I forgot one. There's another resistor right here. So, there we go. There's a connection here, connection here. And we're going to call this one R1. We're going to call this one R2. We'll call this one R3. There's 1, 2, and 3. Now, these are our two open terminals. By the way, this is VS, it's your source voltage, alright? So now, let's find the equivalent voltage and resistance seen at these two terminals, shall we? So, first thing, let's look at the voltage. And I'm going to do this in a different color here, right? I'll just say VTH. What's that going to be equal to? First off, we need to think about this. Since this is an open here, there's no current. The current traveling here, I equals 0. There's nowhere for it to go, right? So in essence, your current in this is just traveling in this loop just like this. So it goes to R1 and it goes to R2, right? Since there's no current in this loop, we really want to find the voltage right here, right? Hence, that's going to be, well, what is it going to be? Doesn't matter what you say, I can't hear you. You're talking to a monitor, right? But I'll tell you, it's going to be R2 divided by R1 plus R2, right? And this is going to be times Vs. It's basically a voltage divider, right? So that's going to be the first one for VTH. Now, let's look at RTH. Let's redraw this one now for your Thevenin resistance. What did we say we have to do? We have to replace the source by its internal resistance. So, if we start here, this is R1. This is R2. Now, we have to replace it. Hence, assuming it's 0, this is a short. So basically, think of it as a piece of wire. There's no resistance here whatsoever, all right? So we want to find out RTH, and that's between these two resistors. So what's the total resistance between those two resistors? Well, when you look at this, it looks like R1 and R2 are in parallel, aren't they? So this is just a wire that comes down and it connects with this one. So if you redraw that one, let me just do a quick sketch. You're coming in through R3, and then you're going to come down here, and you're going to have, this would be R1. This side could be R2. So here's your open voltage, and by the way, let me draw that better. This is R1. Alright? So looking at it this way, what is RTH? RTH is simply going to equal R1 plus, I'm sorry, I'm sorry. Wait a minute. I made a mistake, guys. This is R3. I drew that wrong. That's R3. This is R1 and R2. So, if we do that, that's going to be R3 plus R1 in parallel with R2. Alright? That makes pretty good sense, doesn't it? So that's the first analysis we could try. You can see how it's applied. And of course, then this whole thing, this conglomeration of resistors can simply be replaced, right, by this circuit right here. Sorry, made that first one. Like this. You come down, you come up, come over. This is going to be what? Thevenin, right? And then you're going to go through resistor here, Thevenin. Two outputs right here. All right, there you go. It's a simpler circuit. That's why you're doing it. You only have one resistor and one voltage source. It's beautiful, isn't it? All right. So let's continue. Let's do another example, shall we? This one shows how to do it in a slightly different circuit. It emphasizes we're doing. So the next circuit, let's draw your source. I always do that, don't I? Boom, 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 boom. Here's your source, and we'll call that Vs, and this is plus and this is minus. You bring this over. All right, we're going to go through a resistor. Be R1. Now, here's where it gets interesting, doesn't it? Resistor here, come down. Those two are connected. Here's open. Open. Hey, why not? Open. This is A, this is B, and this is C, right? So, let's have some fun with this one, shall we? Suppose what we're interested in, wait a minute, my fault. This is R2, and this is R3. Alright, so this is R2 and this is R3. So let's try this one. Let's find Thevenin between terminals A and C. Alright? Pretend this B isn't even here, between A and C. Give it a try. Pause the video, and then tell me, and then turn it back on, and we'll solve it together. All right, everyone, welcome back. Let's give it a go, shall we? So, if we're going to do this, we gotta say Thevenin. Now, the Thevenin voltage has pretty much been a voltage divider in our examples, hasn't it? So I would say if we're looking between A and C, we really care about the voltage at that point, right? That's simply going to be R2 plus R3 divided by what? R1 plus R2 plus R3. Right? That makes a lot of sense, doesn't it? How about RTH? Your Thevenin resistance. Well, obviously we're going to have to make a change here with your source, right? So let's do that. Take the source, get rid of it. We're going to replace it. Just replace it here, shall we? It comes down. There's your source, right? And we're just going to replace it with the internal resistance, which in our case we said is a wire, right? So there's no internal resistance. That's what we're assuming here with this analysis. So, what's that going to equal? Well, if we look at this one, it looks like R1's in series with this is by itself. So it would simply be R1 in parallel with what? R2 plus R3. It's like your resistance there for that one. There's your V Thevenin and R Thevenin right there. Alright everyone, let's try something a little different on this one. Let's just have some fun, shall we? So let's try this one. Let's do it between B and C, shall we? Do the same analysis right now, just do it between B and C. And let me take this one thing off, I don't want to confuse people. There you go. And remember, in this case, we're going to have a voltage. And let's just do it this way. 1, 2, 1, 2. Just going to connect here. There's your voltage. This is Vs. Okay? Plus and minus. Okay, give it a try. And why don't you pause the video and turn it on and we'll solve it together. Alright everyone, welcome back. Let's give it a go, shall we? So V Thevenin, what's that going to equal? Well remember, we're looking at these two now, right? So really, we're interested in the voltage at this point right here, aren't we? I mean, that's where it comes back to, right? So if we look at that, V Thevenin really is going to be R3 divided by R1 plus R2 plus R3. Get it? Makes sense, right? It's a basic voltage divider. R Thevenin is going to equal what? Well, what do we have to do? Let's come over here. We're going to get rid of our source voltage. We're going to do what? We're going to replace it with the wire right between the terminals. I call it a wire because it's no resistance. It's really the source resistance, right? Okay. Let's give it a go. What's your Thevenin resistance at this point? Well, look. It looks like on one side here, if you come around here, you're going to have R1 and R2 on one side of it, and R3 is going to be in parallel with those two, right? So you would have basically R1 plus R2 in parallel with R3. Got it? Well, there you have it. That's pretty much how you would do it, right? Now let's do one final circuit here just to give you complete the introduction here to Thevenin's theorem, all right? Now, suppose we have a circuit where we want to Thevenize just a portion of the circuit. This is where it becomes useful, right? And that's what we're going to be using it for in many analysis we do in our amplifiers, okay? So think about it. Here's your source. You're going to come over, come down. Suppose you have here's a resistor, we'll call this R1. And then we're going to have another resistor over here, call it R2. Okay? And then, what happens, come out. call this one R3. That's a 3 there, right? So let's Thevenize R3, shall we? So what we'll do, I'm sorry, let me finish. This is going to be Vs plus and minus, all right? There's your circuit. That's your R3 resistor here. So let's do this. Let's Thevenize it here, shall we? Put it away, right? That's all we're doing. And then, see, let's Thevenize this point right here. Now, when we Thevenize, there are just two things we calculate, right? VTH. And what do we have? We have RTH, right? Those two items, right? So let's look at your Thevenin voltage. What's your Thevenin voltage going to be there? That's pretty straightforward. We're looking at the voltage, obviously, right here. That's going to be R2 divided by R1 plus R2 times your source voltage, V sub S, right? Now, how about your Thevenin resistance at that point? Well, obviously we have to do something. We're going to have to take the source out of the picture, right? Then we're going to have to place where the source was with a wire, which remember it's the source resistance, which is very small. We're assuming it's 0. And now, what is the resistance at this point in ground? What's the resistance going to be? Well, R1 and R2 are in parallel at this point, aren't they? So it's simply going to be R1 in parallel with R2, right? So let's just redraw the circuit, shall we, to see how it's simplified. That's the whole reason why we went through all this stuff, isn't it? So we're going to have a source here. Beautiful, isn't it? All right, let's come up here. This is going to be V Thevenin plus minus. Then what are we going to do? We're going to go through resistor right here. This is going to be R Thevenin. Very nice. And then we're going to come up here. And this is going to be what? R3. You see all we did? I'm just going to draw this. I just took R3 and I put it back there. And that's what this is right here. Isn't this fantastic? It really helps you simplify these circuits, because now you can use this in further analysis, and it's going to make it much easier when you look at the circuit, all right? All right, everybody. I hope this has been helpful to you, and I will see you shortly on the next video. Bye now.